Welcome to the how to use your TI-83 Plus to do simple linear regression analysis. In regression analysis, we have two possible approaches. One is to measure two different aspects of one person, say locus of control and self-esteem. So this person scored 1 on locus of control, 3 on self-esteem. A second person scored 3 on locus of control and 3 on self-esteem. So each pair of scores represents one person. We could also do related couples such as twins or married people or siblings. For example, twin 1 scores a 1 on, say, a test of memory, and twin 2 scores a 3. Right? Another pair of twins, we see a 3 for twin 1 and a 3 for twin 2. So it's important to keep these pairs together for regression and Pearson correlations. The simple linear regression, by the way, is an extension of the correlation procedure. In fact, the first thing we do is plot the data in a scatter plot. We make sure it's a fairly linear trend in our data. We calculate the Pearson R, then we calculate the regression equation. So remember everything about correlation from before. You'll do fine here with regression, just taking the next step. So let's take a look at how to use the TI-83. Well, by the way, let me remind you that we always need the means and standard deviations for the two sets of data. So we will need those numbers here as well. And we will also want to remind ourselves that N is the number of people, not the number of scores. Okay? All right, let's take a look at the calculator then. And we'll just bring it right up into here. And let's zoom down a little bit so we can see our calculator a little more clearly. We turn the calculator on, and we go to Stats, and we do want Edit, so we press Enter. Now I have previously entered some of the data here, the data from the sheet earlier. In list 1 I put twin 1, and in list 2 I put twin 2. Okay? Or in list 1 I put the locus of control data, and in list 2 the self-esteem data. Remember, list 1 is always the X variable and list 2 is the Y variable. So and also recall that on the X we put the predictor variable, and on Y we put the criterion variable. So you need to know which variable is which, criterion, predictor, X and Y, in order to build the list in the calculator, but also in order to draw the appropriate scatter plot and to correctly calculate the regression equation. So once we have entered our data into list 1 and 2, we're then ready to return to Stats, press the Stat key, and now we're ready to Calc. So we scroll over to Calc. Now in this case, since we need the means and standard deviations for both sets of data, we need to calculate the 2-var stats. And in the Calc list, 2-var stats is number 2, so we scroll down to the number 2, we see 2-var stats, and we now press Enter. When we press Enter, we get 2-var stats at the top of a blank screen with a little flashing cursor. We press Enter a second time, and now we get our statistics. Notice X bar, X means list 1, X bar is 4.428. Then we get the sum of squares. We get Sx, which is the sample standard deviation, and that's what we're after, 1.988. Okay, we also see that N equals 7. All right, good. We then scroll down and we get the Y data set, and remember the Y data set was list 2, so our numbers in list 2 have a mean of 5.1428 and a sample standard deviation of 2.478. And that's what we're after for those data. We now have the means and standard deviations for both data sets. We're now ready to calculate the Pearson R and the regression equation. For that, we go to the Stat mode again, press Stat. We now scroll over to Tests. When we get to the tests highlighted, we're going to scroll all the way down to the bottom of the list. And this is going to go 7, 8, 9 along the side, and then 10, and now we're going to get A, B, C, D, E, and E is Lin Reg T-test. This is what we want for both the Pearson R and the linear regression equation. Once we highlight it, we press Enter. and we see that it's asking us if our X list is in L1 and the Y list of data is in L2. Yes, it is, so we simply leave that alone and scroll down. We scroll all the way down to Calculate without changing anything. Scroll down to Calculate. When it's highlighted and flashing, we now press Enter. Well, we get a lot of data here, but what we're really searching for initially is that Pearson R, and you'll see the arrow onto the side indicating there's more information if we scroll down. So we scroll down until we see R equal. We see that R here is equal to 0.2899. Positive value, 0.2899. So we now have our Pearson R. What we would like also, however, is that linear regression equation. Now, typically, we would not do regression unless the Pearson R was significant. So we have an R of 0.289, and we need to find a p-value. And notice our p-value above the DF is 0.528. Well, that indicates a non-significant R. In other words, we see no significant relationship here. Well, the reason for that is I only entered a few, like 7 numbers, and that's really too few for an adequate correlation. However, we're going to proceed as if it is significant. But just be aware, we do need a significant Pearson R before we can proceed to the linear regression equation. Well, when we do go to linear regression, what we're looking for are 2 things, the slope and the y-intercept. You'll notice at the top of the TI-83 it says y equal a plus bx. Well, remember, what we multiply x by is the slope, in this case lowercase b, and what we add to the product is the y-intercept, in this case a. So a is the y-intercept, b here is the slope. So we scroll down looking for a and b, and here we find them. A is equal to 3.54, b is equal to 0.361. Okay, extracting this data then, we can see here that what we have is R equal to 0.2899. We round it off to 0.29, our Pearson R. The slope we see is 0.361, and the y-intercept 3.542, which gives us a regression equation of y equal 0.361 plus 3.54 multiplied by x. And there you have the regression analysis for SLR. Well, that's it. Good luck. See you later. Bye-bye.